Hi everyone, welcome to lecture on design of steel structural elements. Myself M. Dinesh Kumar, Assistant Professor, Department of Civil Engineering, Hindustan College of Engineering and Technology, Coimbatore. In this video, we are going to discuss how to find the design tensile strength of the plates. We have one plate of a dimension 130 mm by 12 mm. This 130 mm is the width of the plate and 12 mm is the thickness of the plate. The steel used is Fe415 grade of quality. So the diameter of the bolt for the connection is 16 mm. So for this case we have to find the design tensile strength of the plate. As per IS 800-2007, the design tensile strength of the plate is the list of the first one, yielding of cross section as per the class 6.2, then rupture of critical section as per the class 6.3 of IS 800-2007, then last one, the block shear strength as per class 6.4 of IS 800-2007. The list of these three is called as the design tensile strength of the plate. The first one, the yielding of cross section. As per IS 800-2007, class 6.2, the yielding of gross section is T suffix Tg equal to Ag divided by gamma m naught, where Ag is equal to the gross sectional area, then Fy is equal to yield tensile stress of steel, then gamma m naught is equal to partial safety factor. So Ag is equal to gross sectional area, that is total area of your plate. So we already have the dimension of the plate. The breadth of the plate is equal to 130 mm. We already have the thickness of the plate is equal to 12 mm as per our question. So the total area, that is gross sectional area, is equal to 130 into 12 equal to 1560 mm square. As per the grade of steel, then Fy is equal to 250 Newton per mm square. Then partial safety factor is equal to gamma m naught is equal to 1.1 as per table 5 of IS 800-2007. While substituting these three values, that is Ag is equal to 1560 mm square, then Fy is equal to 250 Newton per mm square, then partial safety factor gamma m naught value is equal to 1.1, we have the strength of steel, that is strength of plate in yielding of gross section is 354545 Newton. In terms of kilonewton, we have 354.5. So this is the table number 5 of IS 800-2007. As per table number 5 of IS 800-2007, it recommends the value of partial safety factor for the materials. So previously we are finding the value of yielding of gross section. In that formula we have the value of gamma m naught. We have to substitute the value of gamma m naught. So as per IS 800-2007, so the gamma m naught are the resistance governed by the yielding, right? So by yielding, the gamma m naught value is equal to 1.1. So the next, the important partial safety factor for bolted connection, we have to know the value of gamma mb. So the gamma mb for if your fabrication is shop fabrication, the value of gamma mb is equal to 1.25. Then if your fabrication is field fabrication, the gamma mb value is equal to 1.25. So the gamma mb value is equal to 1.25 as per IS 800-2007 if your fabrication is, whether it is a shop fabrication or field fabrication, the gamma mb value is recommended by IS 800-2007 table 5. Then next we have to find the rupture, the yield tensile strength due to the rupture of critical section. So as per IS 800-2007 class 6.3, it recommends the design tensile strength of steel plate in rupture of critical section is T suffix TDN is equal to 0.9 ANFU divided by gamma ml. So the what here the AN is equal to net area of the section, then gamma ml is equal to partial safety factor. So this value also taken from the IS 800 2007 table number 5. So gamma ml value is 1.25. You can refer it this value from table number 5 of IS 800 2007. Here Fu is equal to ultimate tensile strength of the plate. So your grade of steel is Fe410 or Fe415. So the ultimate tensile strength of the steel plate is equal to 410 Newton per mm square. So the value of Fu is depends upon your grade of steel plates. So as per our question, so the value of Fu value is equal to 410 Newton per mm squared as per table 1 of IS 800 2007. You can refer this value from table number of 1 of IS 800 2007. Then the AN is equal to net area of the section. So we have the one critical section, right? So this is my critical section. So in this critical section we have two number of bolt, 1 and 4. So these are the two number of bolts available in the critical section. Then we have to provide 16 mm diameter bolt for this connection. So you have a 16 mm diameter of bolt. So the required diameter of bolt hole diameter for the 16 mm bolt is 16 plus 2. Additionally we have to provide 2 mm for the bolt holes. So 16 plus 2. So the diameter of bolt hole is equal to 18 mm. Then the net area, what is meant by net area means the solid area between the critical section. So we have two bolt holes. So we have to omit these two bolt holes in the breadth of the plate, that is 130 mm. So 130 mm minus two 18 mm dia bolt holes in the 12 mm thickness of plate. So 130 minus 2 into 18 into 12, that is B into T, right? So the total area of the plate is B into T. In this overall breadth of the plate we have two numbers of 18 mm dia bolt hole. We have to reduce this area, this length, this portion from the total solid portion, right? So 130 minus 2 into 18 into T, the thickness of the plate is equal to 12 mm. So 130 minus 2 into 18 into 12, the value is equal to 1128 mm square. So the net area of the section is 1128 mm squared after reducing the bolt holes. Okay, we have two bolt holes in this critical section. Then Fe value is equal to 410 Newton per mm square. Then gamma ml value as partial safety factor is 1.25. By substituting these three values, we get the value of the design tensile strength of the plate due to rupture of critical section is 0.9 into 1128 into 410 divided by 1.25. So the value is 332986 Newton. In terms of kilonewton, 1 kilonewton is equal to 1000 Newton. So the value of design tensile strength. Next, the block shear strength as per IS 800 2007 class 6.4. So the block shear strength is T suffix TB. We have a two formula in class 6.4 of IS 800. So the first one is AVG Fi divided by root 3 gamma m naught plus 0.9 ATN Fu divided by gamma ml. So in this formula we have two values, that is AVG and ATN. So AV, AT. So AV means shear area, AT means tension area. So as per the diagram, the shear area is defined by the starting point of the plate, that is edge of the plate, to the center of the extreme plate. So this area is called as a tension area. So the perpendicular area is called tension area. Okay, so this is tension area and this is shear area. So AV and AT. So AV means shear area, AT means tension area. Similarly, AVG means gross shear area, AVN means net shear area. Then ATG means gross tension area, ATN means net tension area. So net area means we have to reduce the bolt hole diameter. So the formula for AN is equal to, that is B minus N D naught into T. Okay, so this is net area formula. So B means breadth, then N means number of bolt holes in the section, then D naught means diameter of the bolt hole, T means thickness of the plate. Okay, so first one, AVG. AVG means, so this area, right? So this point and this point, we have a two shear area because we have the two failure pattern along the horizontal line. So this and this, so first one and second one, so two shear areas. So 2 into net area formula is B minus ND naught. What is the breadth of this horizontal line? So this length is 35 and this length is 60. 30 plus 60, so B is equal to 35 plus 60. Okay, into, so here we are going to discuss of the gross area. We want to add this the bolt hole diameter also. That's how 35 plus 60, the total length will be taken. Then T is equal to thickness of the plate, that is 2 into breadth. The total breadth is equal to 35 plus 60, that is 95 into 12. So the total cross sectional area is equal to 2280 mm square. The next one, AVN, that is net shear area. Okay, net shear area. So along this horizontal line, how many bolt holes are there? Okay, how many bolt holes are there? So first one, we have a two horizontal line, so that is into 2. Okay, that is into 2. So the length of the horizontal line is 35 plus 60, that is length of the shear plane is 35 plus 60, right? 35 plus 60. Along one horizontal line, how many number of bolt holes are there? So this is full bolt hole. The center, right? Second one is a center. The center point is, so this is my second bolt hole. So up to this we have a 65 mm. So half bolt holes are there, right? 1 plus 0.5, that is 1.5 bolt holes are there. The diameter of the bolt hole is 18 mm. Then the thickness, the T is equal to thickness of the thickness of the plate, so 12 mm. So 95 minus, along the 95 mm length we have 1.5 bolt hole, right? 35 plus 60 in the center. Along the 95 mm we have a 2 bolt holes, that is 1.5 bolt holes. One full length of bolt hole, half length of the bolt hole, that is 1.5 into diameter of the bolt hole is 18, that is 95 minus 1.5 into 18. The thickness of the plate is 12 mm. We have a 2 shear plane, that is into 2. The value of AVN is equal to 1632 mm square. The next one, tension area. So the tension area means, so this is my tension area, right? This is my tension area. So the tension area is, the length of the tension area is 60, right? Center to center distance is 60. The thickness of the plate is equal to 12 mm. So 60 into 12, the value is 720 mm square. So what is meant by ATN? So ATN means net tension area. Okay, so this is my tension area. Along the tension area we have, so this is my tension area, right? So the center to center distance between two bolt hole is 60 mm. Okay, so along in the 60 mm we have top, we have 0.5 bolt hole, then bottom we have a 0.5 bolt hole, so 0.5 plus 1, right? So this is one full bolt holes are there. So 1 into diameter of bolt hole is 18 mm, so 60 minus 18, then thickness of the plate is equal to 12 mm, so 60 minus 18 into 12, the value is 504 mm square. By substituting these four values in two formulas, we have the value of 2 block shear strength. So least of these 2 block shear strengths, so the strength is called the design tensile strength due to the block shear. Okay, so substituting avg atn, then we already know the value of fy and fu, right? So fy means yield tensile stress, then fu means ultimate tensile strength. So Fy value is equal to 250 Newton per mm squared, Fu is equal to 410 Newton per mm squared, then gamma m naught value is equal to 1.1, then gamma ml is equal to 1.25. So substituting these above values, we have the first value as 3. Next, as per the class 6.4, the design tensile strength due to block shear, the second formula is 0.9 avn fu divided by root 3 gamma ml plus atg fi divided by gamma m naught. We already have the value of fu fy, so fu value is equal to 410 Newton per mm squared. Fy, the yield tensile stress of steel is 250 Newton per mm squared. The partial safety factor gamma m naught value is equal to 1.1. Gamma ml value is equal to 1.25. Okay, so fu value is equal to 410 Newton per mm squared. Then Fy value is equal to 250 Newton per mm square. Previously we calculating the value of AVN, that is net shear area, then ATG gross tension area. So the ATG value is equal to 720 Newton per mm square, then AVN is equal to 1632 mm square. By substituting all this value, we get the value of the block shear strength due to the second formula is 479 kilonewton. We previously discussed we have a two value due to block shear, so the least of these two value is the design tensile strength of plate due to block shear. So the least, so as per IS 800 2007, the strength of the plate is the least of yielding of gross section, rupture of critical section, the block shear strength. We have a three value, right? So yielding of cross section depends upon a T suffix dg formula. Okay, then rupture of critical section depends upon T suffix dn formula as per class 6.3. Then the block shear strength is depends upon T suffix db1 and db2. So, okay, least of a db1 db2 is called as a T suffix db. So the least of these three value is the strength of the plate. So comparing these three value, the least of these three value is 332.986 kilonewton due to rupture of critical section. So the strength of the plate is 332.986 kilonewton. If your breadth of the plate is 130 mm, then thickness of the plate is 12 mm. The grade of steel plate is Fe410 grade. Then if you are providing a 16 mm diameter of bolt, so the strength of the plate is 332.986 kilonewton. Okay, so this is the way to find the value of your strength of the plate. As thank you.